So the easy questions with the binomial expansion are expand and simplify completely, which were our first two examples that we did. Then there's one saying, can you find term 9? Can you find term 7? That's just using your formula. It gets a little bit more difficult if they use the following words. So the first two are actually not too bad, but if I wanted you to find the last term of x squared plus 2y to the 4, which one's the last term? Well, the 4 tells you there's 5 terms. The last term in this example would be the same as saying, can you find term 5? So a little bit more thinking, but I would say the last term ones are almost as easy as the one saying just find term 8, find term 9. But you have to know how many terms there are, and you always know how many terms is one more than the exponent. So if this one said find the last term, you'd be like, oh, there's 5 terms. The middle term is a little bit trickier. Ooh, I was going to use the same example, but we might run into a little issue. If I have 5 terms, which term is in the middle? Term number 3. I won't give you a visual of how it's this one, right? Okay. So this same example, the middle one is term 3. Does it make sense that you only have a middle term if you have an odd number of terms? If I have 4 terms, there's none in the middle, because there's 2 on this side, 2 on this side. There's no middle term if you have 4 terms. But 5 terms, you have a middle term. 3 terms, you have a middle term. 7 terms, it'd be term 4. Okay? So there's a couple of different ways. Some people say, well, the middle term, if you always add 1 to the number of terms and divide, right? 6 divided by 2 is 3. Or maybe you take 5 and divide it in half and round up. Right? 5 divided by 2 is 2.5. The middle one's going to be term 3. So the middle term, a little bit more difficult than the last term. But the ones that are the most common, that are more involved, are the ones like, can you find the term contained? So we're going to do a couple of those examples. Find the term containing let's do an x to the 9 in the expansion of 3x squared minus 2 over x to the 9. So first of all, if you did the complete expansion, there would be 10 terms. And if you simplified all 10 of them, one of them will have an x to the 9. This is a strategy you could use, but it's the long strategy. It would take a long time. So what we're going to do is we're going to see how the formula can get us this a little bit quicker. So the formula says, right, here's my formula from my formula sheet. In this case, I would know n is 9. I know what a is. I know what b is. But we don't know what k is, because we don't know which term has an x to the 9. So we're going to have to solve for k. And the only hint that we have is the exponent. So we're going to use the formula. We're going to start off by plugging in what we do know. We do know that whatever term it is, term k plus 1, is going to have a number times x to the 9. then in my formula, I'm going to have 9 choose k. Term 1 is a 3x squared. It's going to be to the exponent of 9 minus k. And the second one is a negative 2 over x. That's going to be to an exponent of k. To find k, since the only thing they gave us as a hint was that it has to have an exponent of 9, we're only going to use the exponents. We're going to temporarily ignore the coefficients. So what does that mean? Well, 9 choose k, that's going to be, here, I'm going to put this space, I'm going to underline it in blue. Do you see that this part is going to be a number? It's going to affect the number in front. I have no idea what the number is in front is, so I'm going to ignore that. I'm going to ignore this 3. I'm going to ignore this negative 2. I'm just going to think about the exponents. Well, I know that my term has an exponent of x to the 9. And on the right-hand side here, I have x's in my numerator. I also am going to have x's in my denominator. Do you see that you are going to have x to the 18 minus 2k in your numerator, and you're going to have x's to the k in your denominator? Exponent rules tell me and from here you'll be able to solve for k easily. We'll do some more of these.
Would the following students please report to the office? Berlin, Powell, Eleanor, Bueno,
Tomorrow.
Brendan,